Good afternoon, class. How is everybody doing?
Yep.
Welcome back from your spring break. Last time we had a session, we had started with 6.4 graphs of the sine and cosine functions. So I want to recap what we've done and we move on. All right, so as I mentioned, we were dealing with section 6.4 last time. And so we've covered a bunch of sections in this chapter. First, the basics in section 6.1, the basics of trigonometry. Okay, there were some definitions as far as angles, ray, initial side, terminal side of an angle, vertex, and conversion between degrees and radians. We also had some applications. We dealt with omega, okay, versus v. V is the linear velocity. Omega is the angular velocity. S, the arc length, r theta, and A is the area of a sector, 1/2 r squared theta. Trigonometric functions, their definitions. If you're dealing with a unit circle, x squared plus y squared equals 1. Okay. Coordinates x comma y represent cosine and sine respectively. If you're dealing with x squared plus y squared equals r squared, then it is the ratio of x to r, which is cosine, and y to r, which is sine. The rest are basically the reciprocals, fairly straightforward. Properties of trigonometric functions. There were some identities that were discussed. Obviously, the fundamental identities such as reciprocal identities, Pythagorean identities, odd and even. Every function, every trigonometric function is odd, with the exception of cosine, in which case secant also, since it's 1/cosine. The two of them are even functions. The period for any trigonometric function is 2 pi. In the case of a tangent and cotangent, is half of that, it's only pi. We looked at sinusoidal functions, sine and cosine. We looked at their graphs, and basically one easy way to approach it is to understand a basic sine. What is the domain? 0 to 2 pi. Same thing for cosine. What is the range? -1 to 1. Same thing for cosine. And then it starts from 0 and it goes to 2 pi because the period is 2 pi. And all you have to do, one easy way to graph it is cut the interval of 0 to 2 pi into 4 equal pieces, 4 sub-intervals, giving rise to 4 arcs, as we discussed last time. And we can graph it in this format. Cosine, the same thing, we cut it into 4 arcs, and we graph that one in the same format. That would be one easy way to handle sine and cosine functions and their graphs. And the properties, honestly, as I mentioned before, with any algebraic function, if you remember the basic graph, you know all the properties. By properties, we mean the domain, the range, the intercepts, and the intervals of increasing, decreasing, and so forth. I believe this example was done, so I want to quickly recap what we did. If we are looking at y equals 3 sine x, and we want to do it by the transformation, we compare it to y equals sine x. We know how it looks like. Y equals sine x has the basic, domain and range and the period and amplitude. And what happens when we are interested in changing it to 3 sine x, the only thing that changes is the amplitude, which was 1, changes to number 3, and therefore it stretches along the vertical axis. And so what happens is everything remains the same. The range, which was originally from -1 to 1, changes to -3 to 3. So this is the synopsis of what we have done. And now I believe this was the last question we did, and I'd like to move on. So let me pause the recording, making sure everybody is in good shape, and then we take it from there. All right, class. So let's take it from here. So we looked at the first example, very straightforward. Here's the second one, and we want to see what happens here. There are a couple of transformations that is taking place here, class. Number one, we notice this negative sign. So first, we can graph sine, the basic function sine x, and the negation sign will flip it over. What I want you to notice is this, class. I want you to look at that piece. Oh boy. And now this has flipped over. It has flipped over. What has flipped over? I'm looking at the main cycle, and then of course it continues indefinitely. As long as you have a complete cycle, then you can move on. It's not a big deal. Now, the next thing is the period. The period is 2 pi, and now because this is 2, we have to divide the 2 pi by it, and as a result, it does affect it, and it shrinks accordingly along the x-axis. So we are replacing x by 2x, okay? And so what happens in essence is this. I want you to pay attention to the result that I'm writing for you. T is 2 pi. In general, it's 2 pi divided by omega, omega being the coefficient of x. It happened to be number 2, it's pi, therefore, the only change that has taken place is with respect to t, or the period of the function. Okay, class? Sounds good?
Yes.
We are going to move on to the next one, class. So negative sign flips it over. 2x will cause the function to shrink along the x-axis because it does affect the period of the function. All right. Same thing happens here. As far as the transformation, we are comparing it to cosine. So we notice a couple of things. One of them is this number 2 in front. So remember, we have the cosine. This is the general shape. And again, we want to pay attention to one complete cycle. Okay? And so what happens then? If we look at a complete cycle, we notice that 2 has an effect which means it's going to stretch it along the y-axis by a factor of 2. In other words, the amplitude of the function changes. So we're going to multiply by 2, and so it does have an effect on the range of the function. The next thing is number 3 and the effect of that. The period is originally 2 pi. You are going to divide that by 3, and basically it shrinks it by a factor of 3 along the x-axis. In other words, x is being replaced by 3x, and the effect is on the period of the function. So let me write this also, t equals 2 pi divided by 3. Okay, I want to make sure we have that, class, okay? So t is 2 pi divided by 3. Sounds good? Everybody okay with that? All right, we're going to next question in a moment. I want to make sure everybody has a chance to digest this. Okay. All right. I think we are fine to go. Now, the next thing I want to look at is the following, and we want to see what is our observation. When we look at the function y equals cosine x, and the function y equals x minus pi over 2, which means we have shifted the function by pi over 2 to the right. So the red one is the cosine function. The blue one is the same cosine function, okay, that has been shifted. And as you can see, it is the same as the sine function. Therefore, we can conclude that sine is cosine of x minus pi over 2. By the way, it so happened that if you write cosine of x plus pi over 2, it means shifted to the left by pi over 2, and it results in the same thing. Now, one way, if we were to approach this from a calculator point of view, we could graph both of them as follows. For y1, we use sine x. For y sub 2, we use cosine of x minus pi over 2. So what do we see? How many graphs? We see only one graph. So that is one way to approach it, to see that they are the same if we were to approach it using a calculator. All right. Here's,
Professor,
yes.
forgive me for asking, but I don't
Sure,
really
of course. I'm sorry, I couldn't hear you one more time, please.
I don't really see the big difference.
There is no difference, exactly. No. That's the point. Okay, let me just quickly recap this so you see what we are trying to do. In this graph, we have two functions. The red one is cosine, the blue one is cosine, shifted to the right by pi over 2. That sounds good?
Well, yeah, that's what I'm referring to. So y equals cosine x is the natural state, and y equals cosine to the x minus pi over 2.
Cosine of x minus pi over 2 is the blue one. Yeah, go ahead. And that looks like a sine, doesn't it?
Yeah, that's what I'm trying to say. So what's
And that's the point. The point is sine is the same as cosine, shifted to the right
Oh,
by pi over 2.
okay. That makes
Sine is the same as cosine, shifted by pi over 2 to the right.
Now, if we were trying to, like we did, in example 1 and 2, to see how we get from, the first step to the second step, how, I don't really understand. My point is, I don't understand how we have, what creates that difference, the minus pi over 2. Is it possible to show us? I mean,
It's a shift. Yes, of course, it's a shift. So here's, okay, this is as good as it gets, class. This is y equals cosine, one cycle. Agreed?
Yes.
Okay, so let's write down what we have here. This is what? 0, 1, pi over 2, 0, right?
Yes.
Pi negative 1, 3 pi over 2, 0, 2 pi 1. Agreed?
Yeah.
Now, shifted right by pi over 2, let's call this y sub 2, and it's cosine x minus pi over 2. So what happens is, okay, now this, and this is not to scale by any means, this point now has coordinates pi over 2, 1, because 0, 1 has shifted by pi over 2 and everything else has shifted by pi over 2. Okay, so what I want you to see as far as this one is concerned, okay, is this one.
So you're basically just taking the point and moving it 1 point.
Look at the one that I did here. This is the portion. If you're looking at one, let me use a different color here. If you look at one cycle of the original function y equals cosine x, one cycle was this one. Yes, that's one cycle.
Yes.
Now look at the, one complete cycle in yellow. It has shifted by pi over 2. And that's what I'm trying to show you at the bottom. Needless to say, my drawing is horrible. You know that. But that's it. It has shifted by pi over 2. What has shifted? Every point of the original function. So if you look at one complete cycle, then the rest makes sense. Is that making sense? Is everybody okay with that?
Yes. Thank you. It makes much more sense, like visually seeing, like you're basically deducting the point or adding, which, I mean, you basically
Now,
shifting.
it is a shift. If you recall when we did the transformation, this is transforming to the right by pi over 2. This is the transformation in one of the first chapters we did. Same transformation, okay? Just for the sake of argument, if you have y equals x squared versus y equals x minus 5 squared, what does it mean? We are shifting to the right by 5 units. That's exactly what's happening here, but the units are in pi, so pi over 2.
Okay. Thank you, Professor.
My pleasure. All right, so let me, well, you've seen the rest of it, so we can keep it like that. So what happens is, in a matter of comparison, what it says, one way to look at it from the point of view of graphing calculator, you can graph two functions. One of them you call it sine, one of them is cosine of x minus pi over 2. If you click on graph, you just see one graph. You don't see two different graphs. So how many graphs do you see? Just one, which indicates they are identical. That's the idea behind using a graphing calculator. Okay, sounds good. All right,
Thank you.
we're gonna go to the next one. Okay, so y cosine x, we said the period is 2 pi, the amplitude is 1, okay? And if we are looking at y equals a sine omega x, then what happens that the amplitude changes. The amplitude is the absolute value of the coefficient of sine, which is a, so the absolute value of a. And as a result, the range will change. And then t is 2 pi over omega, and it changes the period of the function, okay? All right, so here's an example. Let's say y equals -4 cosine x, cosine 3x. We don't want to graph this, we just want to discuss what we actually did in the previous examples. What is the amplitude? What is the period of the function? So I hope you see that the amplitude is, you look at the coefficient is -4, so the absolute value of that is +4. The period is 2 pi divided by the coefficient of x. When I say coefficient first, I meant the coefficient of cosine. It's important to see that. Now we are looking at the coefficient of x. We divide 2 pi by it, and that is our period for this function. What about part B? Can you come up with the answer for part B quickly?
Three.
Amplitude is
3.
and period is
1/2 over omega.
very good.
Pi over
2 pi over 4, which is the same as pi over 2. Sounds good, everybody? Is there any questions? All right, we want to move on. And so the next page, we have already discussed that. What I want to really demonstrate here is using a simple example to make some sense out of this. So I don't want you to get bogged down by this, okay? It's a lot easier to see an example and handle this. So here's the example, y equals 4 cosine 2x, okay? So we want to use the key points to graph this. When it comes to the key points, that means we have 4 arcs. Remember that class, okay? So I'm going to quickly remind you of the 4 arcs for a cosine function. So never mind this question. You are supposed to know the following graph. Okay, class? Now the 4 arcs are, let me use a different color. Okay, let me use a different color again. Okay, so this is number 1, this is number 2, this is number 3, this is number 4. So we know it starts from 0, 1, and it ends up with 2 pi, 1. So you divide the 2 pi into 4 equal parts, and you get those 4 arcs. So what happens that you need to know is that in the beginning we have the maximum, at the end we have the maximum if it's a basic cosine, okay? Then at the end of the first arc, what happens? At the end of the second arc, at the end of the third arc, all of those points are very straightforward. I put it up in the last example. So now that we know that, we are going to graph this. In order to graph this, number one, the amplitude is 4, which means right away, if I was just looking at 0, 1, this 0, 1 is no longer there. It changes to 0, what? Can anybody tell me? Just as an example. 0, 1 changes to 0, comma?
4.
That's it. So this gives you an idea what we are trying to do. And of course, it continues with the rest of it, okay? Now, what happens with the rest of it? Remember, we need to find the t. The period is 2 pi divided by omega, which means 2 pi divided by 2 is pi. Now, the period must be cut into 4 equal pieces. Okay? Again, I want to remind you about the basic cosine. Okay? When we cut the 2 pi, remember, when we cut the 2 pi into 4 equal parts, it gave us 0 to pi over 2, okay? Pi over 2 to pi to 3 pi over 2, and 3 pi over 2 to 2 pi. Everybody understands what I'm talking about, right, class? I'm talking about each arc. There are 4 arcs. So I'm going to repeat that again with different colors. I want to make sure that everybody knows what we are discussing here. So this first arc goes from 0 to pi over 2. This one goes from what? Pi over 2 to pi. The third one goes from pi to 3 pi over 2. The last one goes from 3 pi over 2 to 2 pi. So we cut it in 4 pieces. Each arc had pi over 2, okay? Now this one, when we divide pi by 4, each piece has a range of pi over 4, a domain of pi over 4, a length of pi over 4, however you want to call that. And remember, it starts from 0, okay? So this pi means we are looking at one cycle from 0 to pi, whereas in this graph, we were looking at 0 to 2 pi for a complete cycle. I want everybody to pay attention to that. So it's 0 to 2 pi originally. For this example, is 0 to pi that we're going to cut it into 4 equal parts. What are the 4 equal parts? These are the pieces. We're going to go from 0 to pi over 4 instead of 0 to pi over 2. We're going to go from pi over 4 to pi over 2, pi over 2 to 2, and so on and so forth. Okay? And now what do? So we have the 4 arcs class. The next thing is, for each one of those endpoints, we come up with a pair. For example, for 0, if x is 0, what is pi, everybody? What is y, everybody?
4.
Very good. If x is pi over 4. What is y, everybody? Put it back into the original function, y equals 4 cosine 2x. Replace the x with pi over 4. Y becomes, everybody?
Wouldn't it be 0?
0. So you do the same thing for the rest of it. Okay? So this point okay. All you have to do, plot those pairs. That's all you have to do and connect them, class. Okay? So if we plot those pairs, look something like this. Take a look. This is a complete cycle. If the question is asking for a complete cycle, we're done. However, if it doesn't, then we go indefinitely on both sides. Sounds good? Is there any questions, class? So this is the method of using the key points. So what is the method? Very simple. Find the amplitude. Find the period of the function. Cut that into 4 equal parts. Write the end points for each subinterval. Connect them as an arc, and you're done. We're going to get a couple more examples in the same manner, and I want to show you how easy actually you can graph this stuff. Okay? So here's the next one. Everybody okay with this? Any questions, class?
Oh, we're good.
All right. We are going to do the same thing here. So I'm going to pause it, and I'm going to let you do 2 things. Number 1, find the amplitude. Number 2, find the period. Then we discuss the next part. All right. And so what is the amplitude, everybody?
3.
Is the absolute value of -3, which makes it 3. What is the period of the function? Anyone?
8.
2 pi divided by pi over 4 is 8. Perfect. Okay. And so now what do? We cut that into 4 equal parts. That means we're going to divide by 4, and it gives us 2. There is no phase shift, class. So we start from 0. That means the first one is 0 to 2. 2 to 4, 4 to 6, 6 to 8. So what I'd like you to do is 2 things. Number 1, find the pairs. That means you need to find 5 pairs. Number 2, graph them. Let's pause the recording for a moment for you to do that. All right, class. So for example, when you plug in 0, what do you get? -3. Why is that? Because cosine of 0 is 1 times -3 becomes -3. Okay. And I hope you can find the rest of them. It shouldn't be a big deal, class. Okay. Sounds good. And if you plot those carefully, it'll look something like this. Does that make sense? Is everybody okay with that? Is there any questions, class?
No.
All right, so I hope you see that it's a fairly simple process when we use the key points. And in fact, I highly recommend you do that from now on. This is the fastest way to graph sinusoidal functions. Okay? What is my amplitude? What is my period? What is my phase shift if I have to shift it? And take it from there. So we're going to go to the next example. So we are building up class. So here's the next one. All right. So for this one, I'm going to be quiet for a while. I want you to come up with the amplitude, period of the function, cut it into 4 equal pieces, come up with the pairs. You need 5 pairs and graph. You can do this. By now you have enough practice. This is a sine function, so you know the basic sign and what happens. All right, now let's see the steps quickly. The amplitude, the period, and again, there is no phase shift. We divide it by 4, becomes pi over 6. So the first part would be 0 comma pi over 6. The next one would be pi over 6, and then pi over 6 plus pi over 6 is pi over 3, and you come up with the answer. Now, as an example, if you plug in 0, you get 5 times sine of 0, which is 0. If you plug in pi over 6, 3 times pi over 6 is pi over 2, sine is 1, so it becomes 5 times 1. Those are the 2 that I went over. The rest of them work in the same manner. All you have to do, plot 5 pairs, the end points of the sine function.
Seems like sine's always going to be easier because your ending, middle, and beginning are always going to be 0 regardless.
Well, the thing is because there is no phase shift. There are other things that can happen. We'll see them in a moment. But it is a basic sine function. The basic sine function starts at 0 over 0. I'm sorry, 0 comma 0. Okay? And the maximum occurs 1/4 of the way. So it's important to see the meaning of the key points. Okay? So 1/4 of the period, okay, results in the maximum. Okay? That's the idea. And now if you expand it indefinitely on both sides, it's a periodic function. That makes sense? Any questions, class?
No.
So I hope you see this method is a very simple method. When you want to graph sine or cosine, it makes no difference. This is the method. Of course, we're going to make it more interesting in a moment, okay? But for now, we want to make sure we master this one. All right, I want to go over the next one quickly. Any questions? All right, so here's the next one, class. We do the same thing. Again, there is no phase shift. That means it doesn't shift to the right or left. And so what we do, quickly, we recognize the amplitude is 2, and we divide. Oh, by the way, here's extremely important. Whenever your argument is negative, in the case of a sinusoidal function, you cannot have it. You have to get rid of it. How do you get rid of it? Well, sine is an odd function. Cosine is an even function. In fact, all of them are odd with the exception of cosine. And of course, with cosine goes secant. So you got to take the negative out. That means if it were cosine, you would just get rid of it. Since it's sine, it's an odd function. This is how you take it out. The sine of negative theta equals negative sine theta. That's what we are using, everybody. That's the first thing. So I'm going to repeat that. If the argument of any trigonometric functions you are dealing with is negative, you have to get rid of it.
And this
You
would
can't
work
have it.
It was a 2 cosine as well.
If it was 2 cosine, it would stay the same. Okay. In other words, y is equal to 2 cosine of negative pi over 2x is equal to 2 cosine pi over 2x. That's the same. Because cosine is an even function, because, let me write it with a different color, because cosine of negative theta is the same as cosine theta. When we discussed fundamental identities, and one of them that we discussed was the odd and even function. Sounds good, everybody? We're going to move on. So the amplitude is absolute value of -2. Then the period is 2 pi divided by pi over 2, okay, which makes it 4. That means the period really is going to be from 0 for one cycle is from 0 to 4. That's the meaning of it, okay? And so we're going to cut this into 4 equal parts. So we're going to go from 0 to 1, 1 to 2, and the rest of it. Now we plug in 0 into, now we are going to use this function. It doesn't matter really, you use the original function or this one, makes no difference. Now you're going to plug in 0, 1, 2, 3, 4, and it results in the following pairs. You graph them carefully. 0, 0, 1, -2, 2, 0, 3, 2, 4, 0. Notice the effect of that negative anyways. The sign has flipped over as expected, right? You see that, everybody? So it will work out whether you go with the transformation. Okay? The transformation being you stretch it by a factor of 2, you flip it over, okay? So one more time, you stretch it by a factor of 2 along the y-axis, you flip it over with respect to the x-axis, and then you do the stretch along the x-axis by a factor of pi over 2. That's the same as, if you did the transformation, that's the same as this one. Of course, if you want to look at the graph of the periodic function, we continue indefinitely on both sides. It is important to understand a complete cycle and then moving on. I'm assuming we are okay with this, so we can move on with the next question. Is everybody done, class?
Yes.
Excellent. All right, we're going to discuss everything here as to what's going to happen. And the way we approach this is very simple, okay? First, if you look at, there are two ways to approach this when we have shifting up and down by a factor of some number. As you notice, we have this -2 here. There are two ways to deal with it. One is to completely ignore it, and at the end, you shift it down by 2 units. This is one way to do that. You want to discuss that? I'm going to mention the second method also in a moment. So for now, if we ignore that, this is what we have. For now, we're going to ignore the -2. Now there's nothing brand new here. We've seen this all along. So that -4 gives the amplitude of 4. T is 2 pi divided by pi. Okay. we cut this into 4 equal parts. So this is, remember, this is 0 to 2, okay? And so 0 to 2 is cut into 4 equal parts. So it's 0, 1/2, 1/2, 1, and so on and so on. So far, we are just repeating the same thing that we have seen, nothing brand new, class, okay? Now, we come up with the pairs accordingly. And we plot those. Again, we are not paying attention to that -2 at all, class. Not yet, not yet. This is one way to do it, not yet. Completely ignore that. You can continue indefinitely on both sides. Okay, and so what happens is very simple. You shift it down by how many units? 2 units. Class, when you shift it down by 2 units, pay attention to each point. Let's start with the basic. 0, -4 becomes what? 0, -6. 1, 4 becomes 1, 2. Okay. 1/2 0 becomes 1/2 -2, so on and so forth. Is everybody following that? Because yes. I want to quickly explain the second method.
Okay.
So this is one easy way to handle this, and that works, class. The second method is this. This is X, this is Y. This is the line Y equals -2. So, the way you approach this, you assume your x-axis is Y equals -2, and you plot these pairs. Is everybody with me? Let me just make sure everybody understands. We go through the same process. If you assume Y equals -2 is your x-axis, and you plot those pairs, you get exactly the same graph. Now, which one is easier? I have no idea. You make a decision. So I'm going to repeat quickly what we are going to do. If we want to go with just the key points and sticking with that, we find the amplitude, we find the period, we divide it by 4 because there are 4 arcs. We make up 4 subintervals. From the 4 subintervals, we get 5 pairs. We graph them, we're done. That's all there is to it. Now, of course, this is a complete cycle. We go indefinitely on both sides. But because of the shift, and that's important to understand, what you can do when you get that part, you have a choice of doing the shift by shifting it down, or put the pairs, instead of using the x-axis, use y equals whatever it is. If it was, instead of -2 class, instead of -2, let's say it was +7, you would use y equals 7 as your x-axis. Is everybody with me?
Yes, it's much easier.
Again, and I have no idea which one is easier. You decide, but understand, I have approached both ways, and I think sometimes I found this way is easier if I just do the transformation along the y-axis first by drawing my horizontal line. Y equals -2, y equals 7, and I assume that's my x-axis. I put the pairs, and that's the end of this story. Okay. I'm going to move on at this point. We are going to take a 10-minute break. So we take. Okay. Didn't I start the recording? All right, class. Let's just continue on. We want to find the equation of this graph. Okay. And of course, we recognize it looks like a cosine function. Okay. Everybody can hear me, right, class?
Yes.
So y equals a cosine omega. So we need to find the a and omega, and we are done. So what we notice is that is clearly number 3, right, class? Because 0, 3 instead of 0, 1. Okay. Normally we have 0, 1 here. Remember, this point it's been 0, 1. Now it's shifted to 0, 3, and that shows the amplitude must be 3. T, period, is 2 pi divided by omega. Okay. Omega is 2 pi. So T is 2 pi divided by omega. Okay. And so we have 3 cosine 2 pi x. This is, I want to make sure everybody understands what I'm referring to. Let me, that's a good color. Okay, so we have a complete cycle from here to here. This is that. You are looking at a complete cycle. And so therefore, t equals 1. So you look at a complete cycle of the graph. The graph looks like a sine, looks like a cosine, and you make a decision. So we needed to do 2 things. We looked at by the way, the sine, the regular sine function, it starts with 0, 0. Basic sine function. A basic cosine function starts with 0, 1. Okay? Again, we really need to remember both graphs and the general shape. Okay? Here's the next one. I'm assuming we are okay with this, right, class? Sounds good? So here's the next one. So what type of a function it looks like when it gives us the period? It looks like a sine that has flipped over. So it is a sine and it has flipped over. We can tell, okay, the 0, 0 is intact. Okay, remember. Now, the maximum normally occurs at pi over 2 comma 1, normally. But in this case, let me just draw a complete cycle. So it goes from here to here, down here. Okay, so the period is equal to 4, and omega is pi over 2 as a result, because 2 pi divided by omega equals 4. So omega equals pi over 2, replace it, you have your function. Don't forget that the amplitude is 2, but A is negative 2. How do we know that? It is a sine function that has flipped over. Okay, the graph shows that. Now, this is what you have to do when you're done. You have to check your work. So how do you check? Just check a few points. What points? Important points. Look at the initial value. Okay, again, I'm looking at, I mean a complete cycle, no more, no less. Okay, class? So if you look at the complete cycle, look at the first one. Okay, look at this point, look at this point, look at this point, look at this point. Just the points that we need. Remember, when we graph the 4 arcs and the end points, you can check those points and you're done to make sure it works. Okay, so
Do you mind showing example 10 one more time? I just missed one note there.
you want to see example 10, you said?
Yes, please.
Sure. I'll go over that in a moment. Just as an example, if you plug in number 3 class here, what do you get? You get 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times negative 2, positive 2. And that's what you get, just as an example. So you really have to check with more than one point to make sure it's correct. I'm going to go over the previous page. I'm assuming everybody's done. I want to quickly show you example 10 because it was asked. Everybody done with number 11? Perfect. So here's number 10. Sounds good? And again, the same thing here. When you come up with the function, you want to check by putting a few points in there. Okay?
Thank you.
My pleasure. All right, let's quickly see what we did. And what's coming up. All right, so we are looking at section 6.5. So we're going to look at the graph of the other trigonometric functions quickly, of course, tangent, cotangent, cosecant, and secant. Okay. So just a quick recap. 6.1, the basics of trigonometry. 6.2, unit circle. Okay. And definition of a sine and cosine. 6.3, trigonometric identities. In fact, I want you to pay attention to this one. This question came up. I want you to look at even and odd properties class. It's an important property for you to know. For example, we looked at this. When we were graphing sine of minus theta changes to minus sine theta. So you never ever graph a sinusoidal, a trigonometric function with the negative argument. You always get rid of the negative argument accordingly. So we did the graph here, okay, with regards to sine and cosine. So we've done that, and now we are going to go to look at different functions. For example, tangent here. Y equals tan x, okay, class? To look at the graph of y equals tan x, again, you can easily pick up points and graph, okay? This is one example. I don't want to, dwell on that class. I just want to give you an idea. If we have a restricted x, what happens? You pick up just a few points. For example, for those values, all of this is posted. I just want you to see the idea. You calculate, pi over 3. Let's go over the positive side. 0, tan of 0 is 0, so it gives you 0, 0. Pi over 6, tan is square root of 3 over 3. Pi over 4 is 1. Pi over 3 is square root of 3. Now, the negative side is just a negation of that. So if you write those pairs and plot them, it'll look like this function, just as an example. So what is the point of this? The point is, how do you graph a function you've never seen? Well, you just plot points. There's no other way. We are just plotting. Now, if we do that, for a general case, it'll look like this. What I want you to pay attention to is the following. There are a couple of very important things that I want you to see. This is one complete cycle. Everybody can see that? Maybe, let me just do this part. This is a complete cycle. One idea to help you remember the graph, it looks almost like y equals x cubed. Okay? Now, what we are looking at is infinitely many vertical asymptotes. Why is that? Because tangent is sine over cosine. Wherever cosine is 0, we have vertical asymptotes class. Okay, so vertical asymptotes occur when the denominator is 0. So take a look at this information. I want to go over that, and I want to make sure everybody understands what I'm talking about. Y or tan x equals sine over cosine. So what is the domain? Denominator can't be 0. So cosine x equals 0 gives us 2n plus 1 times pi over 2. What do we mean by 2n plus 1 divided by 2? Okay. Odd multiples of pi over 2. Class, this means odd multiples of pi over 2. That's the meaning of 2n plus 1. So those are the points where cosine becomes 0. And those are the points that we refer to them as vertical asymptotes. Range, there is no restriction. We already established that every trigonometric function is an odd function with the exception of cosine. So cosine is not. Cosine is an even function, so is secant. The rest of them are odd functions. So domain, it is related to the vertical asymptotes. Vertical asymptotes, 2n plus 1 times pi over 2. Domain, everything but. X-intercepts. Remember, a fractional expression. A fraction is 0 when the numerator is 0. So y equals tan x is 0 when sine x is 0. And sine x is 0 when x is n pi. So I hope this is very straightforward. Is everybody okay with this? You really need to remember this stuff to be able to move on. So here's what's going to happen. We're going to look at a simple example and see how the graph works. Y equals 2 tan x minus 1, and first and foremost on the right, top right, I'm writing the general idea behind tangent. When y equals tan x, the period is pi, which means we go from negative pi over 2 to pi over 2 for a complete cycle. Let me go back. I want to show you the one that I did here, class. A complete cycle goes from negative pi over 2 to pi over 2, x equals negative pi over 2, and x equals pi over 2. Both of them are considered vertical asymptotes. This is a complete cycle. It continues indefinitely on both sides. Now, what about 2 tan x? First, notice the period is not changing. The period remains the same as pi. So what does that mean? That means we are going to go from negative pi over 2 to pi over 2 as a complete cycle. It's important to understand that concept. So the period tells us what is where a complete cycle goes. A complete cycle, you cut the period in half. Okay, so in this case it's pi from negative pi over 2 to pi over 2. Now, the next thing is, so let's look at t equals pi. The vertical asymptote, okay, remains the same. Okay, so what is the effect of 2? Well, it stretches by a factor of 2. For example, if we have this graph, okay, couple of very important aspects. 0, 0 is there, class. Pi over 4 comma 1 is there. So pi over 4 comma 1 will become pi over 4 comma 2. Are you with me? First. And negative pi over 4 negative 1 becomes negative pi over 4 negative 2. That would be the first transformation by a factor of 2. So we're discussing transformation. The first transformation is the effect of number 2. And by the way, they don't have amplitude, okay, class, tangent, and the rest of them. Amplitude refers to the amplitude of sine and cosine. All right, the max and minimum value that the amplitude can cause a function to have. And so this is the first part. The next part is the effect of negative 1. What is the effect of negative 1? Okay, the effect of negative 1 is shifting 1 unit down. As a result, pi over 4 comma 2 now changes to pi over 4 comma 1. 0, 0 changes to 0, negative 1. Negative pi over 4, negative 2 changes to negative pi over 4, negative 3. Sounds good? Everybody okay with that? Any questions? I want to make sure everybody can see this transformation, everyone. So there are a couple of simple steps. Pay attention to the period of the function. Again, remember class, when the functions become involved, you can always use a calculator, but we want to make sure we can handle the basics, okay? That's the idea behind the course. So here's the next one I'm going to also look at, and then the third one, let's give everybody a moment to do that. So let's look at the second one together. I'm assuming we are okay with this. All right. So here's the next one. The first thing we notice, and that's extremely important, is the period. The period is normally t equals pi, but we see that the argument of tangent is no longer x, rather 2x. So we need to divide the pi by the coefficient of x. So what happens is the very first thing that happens, your period shrinks, okay? And instead of going from negative power 2 to power 2, you really go from negative power 4 to power 4. I want you to know that that's really the main thing that happens here. However, again, starting with the vertical asymptotes, which was 2n plus 1 over 2 times pi, now it's times pi over 2. I want you to understand what happens. Look at the pi that is given up here. Okay, let me use a different color. This pi is used here. And so now this is used. And instead of pi, you use pi over 2 divided by 2 gives you pi over 4. Is everybody clear how we arrive at the vertical asymptotes? So I want to make sure everybody get that. T equals pi is right here. T equals pi is right here. Okay. Now change it to pi over 2. It results in pi over 4. All right. So that's that. So we have a stretch of 3. So this means stretch by a factor of 3. So we have the basic tangent. It's going to stretch by a factor of 3. That's not a big deal. So 0, 0 remains unchanged. But pi over 4 comma 1 changes to pi over 4 comma 3. So that's fine and dandy. Negative pi over 4 and negative 1 changes to negative pi over 4 and negative 3. So I want you to look at those 3 important points you always need. Look at those 3 points. And this is a very easy case. Now what happens is that the period is pi over 2. Therefore, the change is your vertical asymptotes are no longer at negative pi over 2 and pi over 2. X equals negative pi over 2 is gone. X equals pi over 2 is gone. And it's half of that again. X equals minus pi over 4 and x equals pi over 4. So everything that you have as far as the x coordinate is concerned, it is cut in half. It is cut in half. That's the effect of this. Sounds good? Everyone?
Yes.
All right. The other method, if you want to graph this without the transformation class, you can always start in the following manner. If you want to do this without the transformation, I'm looking at one complete cycle, okay, class? All you have to do is start with the following. This is not to scale, class. So do that as your vertical asymptotes, okay? Why is that? Because the T says so. Now, pick up those 3 points, 0, 0, so plug in 0. That gives you 0, 0, okay? Plugging half of that pi over 4, class. You see this pi over 4? Half of that. So you got to plug in pi over 8 to see what you get, which is 3 times tan of 2 times pi over 8, which is pi over 4, which tangent is 1. 3 times that is 3. So that gives you the point. This is not to scale. Pi over 8, 3. You find the other one in the same manner by putting x equals minus pi over 8, and you graph it. Sadly, this thing bleeds. I don't know why it does that. And it looks horrible. My apologies. But in any event, you do the transformation. That's one method. The second method is you find the vertical asymptotes first, and then a few points corresponding to common arcs will do the job. All right, here's the one I want everybody to have a chance to do it on their own. So I'm going to pause the record. All right, class. First, I want to show you the method that I was discussing in the previous page that makes life easy. First and foremost, t is 2 pi because you divide pi divided by 1/2. Remember, this is x over 2, so this is really three tangent of 1/2 x. So t equals 2 pi, okay? So, and the vertical asymptotes as a result become n pi, okay? So, so the vertical asymptotes are changing as a result, okay? And so what I want to do is to graph the method that I showed you. So, and then I'm going to erase this, okay? Because t equals 2 pi, I'll go with half of that. X equals pi. See, you see that? T equals 2 pi, cut it in half, and those are your vertical asymptotes. And you can see if you replace the x in the function 3 tan 1/2 x, and 1/2 x is what matters, okay? And what you do, if you plug in, you end up with the, so 1/2 times pi, or pi over 2, and that approaches infinity. Remember, tan of pi over 2 approaches infinity. And if you plug in negative pi, tan of negative pi over 2 approaches negative infinity. So that works. Now, you can use the easy pairs that we used. Of course, 0 was one of them. Okay. So if you plug in 0, you get 0. Okay. Then remember what we do. Normally, we use the easy way out. We used pi over 4, okay? Now, actually, because the period is no longer pi, it has been doubled up. Remember, it has been doubled up. So instead of pi over 4, we use 2 times pi over 4, or pi over 2. So if you plug in pi over 2 here, you get pi over 2 divided by 2, which is pi over 4. Tan of pi over 4 is 1, times 3 is 3. So pi over 3 corresponds to 3. So this is pi over 2. 1, 2, 3. So this is the pair pi over 2, 3. And you can use negative pi over 2, and it gives you the same answer, but negative. And so we have this point. Let me try to use a different color, and I try to connect them. That would be my graph if I didn't want to do the transformation. I hope everybody's following. So I'm going to quickly recap. I pay attention to the period, cut the period in half, and I get my asymptotes. I'm talking about one complete cycle. Because the period is 2 pi, half of it is pi. So x equals pi is one of the vertical asymptotes, x equals negative pi is the other one. Now I pick up the easy pairs. Normally pi over 4 gives us 1, negative pi over 4 gives us negative 1. So we try to find a point that is similar to that. And this would be the graph. Can I assume everybody's done so we can erase it and see the transformation? Okay, all right. I assume we are okay with this. Okay, class. All right, so let me erase this in the middle. This would be without the transformation. It's a fairly easy process, class. Okay. Without the transformation. Now, with the transformation, we know the basic function. Okay. So we look at the vertical stretch by a factor of any number in front of a tangent, happen to be number 3. And then we replace it by x over 2, which means it stretches it along the x-axis accordingly. Okay. All right. We're going to move on. These are different methods of graphing M class. This would be transformation. All right. Let's go to the next few functions and look at their graphs. You're supposed to know the general shape class. You don't have to worry about graphing with details that much, but you really need to know sine, cosine. Those are the most important ones that you come across in your, science courses. But you should be familiar with the rest of them. So, but if it gets involved, you can always do graphing calculus. So this is tangent. Here's the cotangent class. Again, I don't want to go and waste too much time on that. How do you graph it? I have no idea. I plot pairs. That's how it becomes, okay? In the beginning, we don't know how the graph looks like. But remember, cotangent is cosine over sine. Therefore, let's discuss a few things, okay? What is the domain? Denominator can't be 0. So sine x can't be 0, x can't be n pi. Range, all real numbers. It is also an odd function. What is the period? Just as tangent is pi. What about the vertical asymptotes? Okay, whatever makes sine 0, whatever makes the denominator 0, and that would be x can't be n pi. What about the intercepts? A function is 0, a fractional expression is 0 if the top is 0. When cosine is 0, you get 2n plus 1 times pi over 2. Remember, that means odd multiples of pi over 2, comma 0. So if you want to concentrate in one, let me use a different color. Period. In the case of cotangent, no, actually I should go with the parentheses. We graph from 0 to pi. Let me make sure everyone understands what that means. In the case of a tangent, we graph from negative pi over 2 to pi over 2. In the case of a cotangent, we graph from 0 to pi. So x equals 0 and x equals pi are vertical asymptotes, and we have more of them, infinitely many more. Sounds good, everybody? So this is general shape. I want to discuss the other functions. The way secant and cosecant work, cosecant by definition is 1 over sine. In the case of a secant and cosecant, it so happens if we want to graph them, you don't have to worry about them at all. Just graph sine. Then flip it over. What do we mean by that? I want you to see this graph, class. I want you to see the sine function. You graph the sine function, and then flipping them over means this function. Okay, so this is flipping it over. And it continues indefinitely on both sides. So how do I graph cosecant x? I don't. I graph sine x. That's all there is to it. Just remember that. So when that happens, it generates vertical asymptotes. So wherever sine is 0, we have vertical asymptotes because cosecant is 1 over sine. Okay, is everybody with me? So y equals cosecant x is 1 over sine x. Domain, whatever makes sine 0 is out. That means n pi is out. And immediately that becomes the vertical asymptotes. Range, all real numbers, except what's in between -1 and 1. So I want you to see that from here to here, that means from -1 to +1, we don't have anything. But -1 and 1 are included, okay? In between, there is nothing. So the range is all real numbers, things, numbers between negative and +1. Is it odd or even? Take a look at sine. Because sine is odd, so is cosecant. So one more time. How do I graph cosecant? I don't. I graph sine, and I flip it over. What about secant? Exactly the same thing. I'm not going to graph secant. Secant is 1 over cosine. So I'm going to graph cosine. Take a look at the cosine function, class. The blue one is the secant function. Okay? And so we graph the cosine, we flip it over, and that's secant. Now we should be able to write the domain, everything except what makes the denominator cosine 0. So that one is out. And when that one is out, that becomes the vertical asymptotes. Range is the same as cosecant, okay? By the way, the period of secant and cosecant are the same as sine and cosine. Is it even or odd? Well, look at cosine. If cosine is even, so is secant. Sounds good? Everybody okay with that? So let's actually, let me use a different color to show you a complete cycle. Just one cycle. You just flip it over. You graph it, flip it over. I hope it's clear. Sounds good, everybody?
Yes.
Let's move on. So if you come across a couple of graphs, you can approach them this way. If they get complicated, you can always use a graphing calculator. So here's the next one. Just as an example, let's see what happens here, class. 2 cosecant x minus 1, okay? So the first we do, we completely ignore cosecant x. We graph sine x, okay? So we graph sine x, we flip it over, and it looks like this. So we graph sine x, and then cosecant. We multiply by 2, okay? Which means the y coordinate doubles up. You can graph 2 sine x and flip it over. That's another way of doing that. Now, minus 1 brings it down by a factor of 1. So this is the graph of 2 cosecant x minus 1. So graph the sine x, flip it over. That's really the bottom line, okay? So if you want to graph it, you can use the sine to get there. And if you are dealing with secant, you want to graph cosine to get there. I want to go over the last question, so we have some time going over the next section. We have a lot to do. I'm hoping everybody is comfortable. You obviously have to some time going over this stuff, class. I understand that, but
Oh, you're cutting off a little bit.
I'm sorry. Did you hear me? My apologies.
Yeah, it was cutting a little bit right there.
Yeah, that's boy, that's the beauty of
I know.
technology. What can I tell you? Sometimes things happen. But all right, so we are okay, everybody, right?
Yes.
All right.
So would you mind
So
repeating the
here's
last part?
one more time.
Can you please repeat the last part? You were cutting up a lot. I didn't catch what you said.
Okay, okay. All right. So number 1, graph sine, flip it over, becomes cosecant. The next thing, 2 cosecant x. So you multiply it by a factor of 2, which means you can graph 2 sine x, flip it over, becomes 2 cosecant x. Last one, subtract 1. That means bring it down by 1 unit. So as an example, this point, which is pi over 2 comma 2, becomes pi over 2 comma 1. And by the way, the period is just 2 pi because this is x, okay, class? And you shift it down by 1 unit. Okay? Is everybody okay with that?
Thank
So
you.
the third one, you can say graph was 2 sine x minus 1 and flip it over. That has the same effect. Okay? Sounds good, everybody?
Yes.
All right. Here's the last one. The application, how it works, that's interesting. It says 2 of 3 feet and 4 feet wide meet at a right angle. Okay? That's it. We want to show the length of ladder, okay, is given as L equals 3 secant theta plus 4 cosecant theta. I want to show that. Actually, we have a very interesting application. I always go over that when we go over calculus. We have something called optimization and how we can minimize the size of this ladder. And so we discussed a question similar to that. So now, here's a fast approach. Take a look at what happens here. So I'm going to do it again. What we are going to see, everybody can see the angle theta. So because that one is theta, okay, we can come up with the other ones. And so we need to come up with the x and y and add them up. So I want you to pay attention to the drawing I'm going to give you. The small triangle is this one. The angle, x is the length. So what do we notice? Cosine theta, and by the way, this is 3, everybody. So cosine theta is 3 over x, and x is 3 over cosine theta. Yes? Is everybody okay with that?
Yes.
And what is that? 3 secant theta, isn't it?
Yeah.
Now look at the other one. I do the drawing next to that. What am I drawing? This one, class. Okay? So what is y? We can find that easily, y, because sine theta, okay, can be found as the opposite, which is 4. Remember, this is 4 and so is this one, okay? 4 over y or 4 over sine theta, which is what? 4 cosecant theta. The length of the ladder is x and y, add them up, and that's a proof, believe it or not. Sounds good, everybody? Any questions? All right. We are going to go to the next section. Are we ready for that? All right, so I don't want to go over the recap. We've done it many times. You really want to make sure that you spend some time going over the previous stuff, being comfortable with them. So I do that because I've seen sometimes students having a little bit of the difficulty with trigonometry functions. So this is it. Now, in this section, we deal with the phase shift, everybody. Phase shift, which means moving along the x-axis. So we want to graph sinusoidal functions. We are normally interested in a complete cycle. As long as that one is fine, then we can extend it indefinitely on both sides. So if function is given y equals a sine omega x minus phi plus b, where we are assuming all of them are positive, A, omega, and phi, we can say the following, okay? If we factor the omega class, so I want you to see what happens from here to here. We factor out the omega, and x becomes by itself, so it's x minus phi over omega, okay? Now, when you write it in this format, your amplitude is still A, your period is 2 pi divided by omega, your phase shift is phi over omega, okay? And so if omega is positive, that means this negative sign remains unchanged and it shifts to the right. If it's negative, the negative sign changes to positive and it shifts to the left. So I don't want you to worry about that. Everybody remembers the basic transformation that has been discussed in previous chapters. The same thing works here. So I want to show you how we can easily graph this by using the same principle, namely finding our period, okay, for a sinusoidal function, cutting them into 4 equal parts, and finding 5 important points. That's all it takes. It's that simple. So let's quickly go over that, see how the phase shift works. So this page explains it, which you can look at later on. But what I'd like you to do, instead of bothering with that, let's start with a very simple example to see how this thing works. Because you may read this and it may, may not make that much sense. All right, so here's a simple example, y equals negative 2 cosine of 4x minus pi. And we want to use the proper method that we have learned to graph it, and the method that was discussed, the easy way out was using the 4 arcs and the easy key points. So the very first thing, notice, sitting next to x is 4. So we have 4x. We need to take it out. Okay? When we take it out, class, it looks like that. Now we are going to compare. What is the amplitude? The same as we have seen it before. The absolute value of negative 2 is 2, so that's not a big deal. The period is 2 pi divided by the coefficient of x, omega, which is 4. So the period is pi over 2, and we are supposed to go from 0 to pi over 2 if we didn't have any phase shift, class. But what is the phase shift? The phase shift is pi over 4. So I want everybody to understand what's going on, okay, before even. So understand pi over 4, okay, and with the negative means to the right, okay, class? If it was plus pi over 4, we go to the left. Now, your basic period is 0 to pi over 2. A complete cycle goes, okay, your period is pi over 2. A complete cycle goes from 0 to pi over 2. And now we're going to shift it by pi over 4 to the right. So we are going to add pi over 4. So now instead of going from 0 to pi over 2, we have to go from pi over 4 to 3 pi over 4. What did we do? We added pi over 4 to both ends. Is there any question up to here? Is everybody following these steps? Because if you do, the rest of them repeat and are extremely simple. Is everybody following this? Is there any questions, class?
No.
Okay, very good. Now, we want what? 4 parts. So we are going to divide the period by 4, and it gives us pi over 8. We are dividing the t by 4, we get pi over 8, which means this. Okay, let me just hold on a second. Which means we want 4 pieces, and the first piece starts with, okay, let's choose a different color. The first piece starts with pi over 4. Remember, we want to write 4 of this. Are you with me, class? 4 of this. How do we write that? That's really the idea. So we are starting with pi over 4. Is everybody following that? Then what happens? We just add pi over 8, pi over 8, pi over 8, pi over 8, and we get the 4 pieces. Okay? So when you put pi over 4, add pi over 8, you get 3 pi over, and then you keep on adding pi over 8. When you add those, look at the pieces that you come up with. Okay? I want to make sure everybody understands what they are, so let me just write this for you as a result of that. So the first pi over 4, when you add pi over 8, you get what? 3 pi over 8. The second subinterval, 3 pi over 8, pi over 2. The third subinterval, pi over 2, we add pi over 8, 5 pi over 8. The last subinterval, 5 pi over 8. When we add pi over 8, we are supposed to get this last piece, and we do get that, okay? So these are the 4 subintervals resulting in 4 arcs. So what do? Every endpoint, we put it back into the original function, and we evaluate, we come up with the y coordinates as follows. We plot those pairs. Okay, class? Let me make sure everybody understands. Okay, pi over 4, negative 3 pi over 8, 0. We are putting it back into the original function. Pi over 2, 2, 5 pi over 8, 0, 3 pi over 4, negative 2. This is a complete cycle, continuing indefinitely on both sides, and this is your function. Is there any question? Is everybody following this class?
Yes.
I want to quickly go over one example. I was hoping that we go faster. It didn't happen, but you have time. Let's go over one more example, then you can put your name as a row sheet in the class and bail out. Is there any questions? So with a couple of examples, you get a hang of it, and it's really easy, okay? With this method, I promise you, This is the fastest and easiest way to graph it. So here's the next one. We want to graph this function. And notice number 2, so we divide by number 2, and it gives us this. So we see that the amplitude is 3, and the period is 2 pi divided by 2. So a complete cycle is supposed, with the period of pi, is supposed to go from 0 to pi if there is no phase shift. But we have a phase shift to the right of pi over 2. So remember, this means to the right, everybody. Minus. If it was plus, would be to the left. So if it were plus pi over 2, we would subtract pi over 2 from both ends, from this end and this end. So now instead we're going to add. And so a complete cycle, instead of starting from 0 and ending at pi, it's going to start at pi over 2 and ends up at 3 pi over 2. Is everybody clear? So we are repeating the same thing we did in the previous page. We cut the period in 4 equal parts. And now we are adding. So as an example, the first one class, now we want 4 intervals, remember that. So the very first one ends up, so here's what's going to happen. So let me just put it here so you see, up here actually. The first one starts with pi over 2, and the last one should end up with 3 pi over 2. Are you with me? So all you have to do, add pi over 4 to pi over 2 and put it here. That's the idea. And keep on adding pi over 4. So when we do that, we end up with the following. So the first one, for example, is this. And you move on with the rest of them. So you evaluate the function at the endpoints. What are the endpoints? Pi over 2, 3 pi over 4, pi, the ones that I've written in a green class. 5 pi over 4, 3 pi over 2. We evaluate the function, and all we have to do, plot those pairs only. And that's a complete cycle class. What's next? Just continue indefinitely on both sides. Okay, it's not the same scale, but I hope you're following the concept. Any questions, class? Is this clear? Is everybody okay with this?
Yeah.
All right. We take it from here on Thursday. If you have a question, you're more than welcome to ask, or stick around and ask. If not, just, we will look at more examples later on. Just put your full name, class,